All right, well, it's my pleasure to get a chance to talk to people here in San Diego about straw bale yet again. It's kind of an interesting history, the way this developed, and we'll go through that with the slides. And I've been fortunate. The thing I've enjoyed most, I think, along the straw bale trail is working with the people that have helped pioneer this. And it's a great delight to have Mott's here for that reason. All started out, if somebody could turn on the projector for me there. It's not intentional. I saw some before. And what we're most commonly talking about is plastered straw bale construction, although as you'll see there's various ways of plastering, and some people never get around to the plastering. We've actually found some fairly interesting references to the use of straw in buildings a long time ago. I just barely missed seeing a building in England that was a timber frame building like this and had bundles of barley straw that had been hand-tied, placed in the timber frame, and then plastered inside and out. And it had been just remodeled and yuppified shortly before I got there, so there was no evidence left. But this building had apparently been built in about 1400. So it had survived from 1400 to 1995. The rediscovery of straw building, and particularly bale building, took place in the sand hills of western Nebraska. Not very good tape back then either. And one of the reasons they were looking for alternatives is, what else have you got? Where are the trees? There are no trees. In places where they had a little better turf and a muddier or clay soil, they could do sod houses, and many people still live in the sod houses as well. Quite often they don't even realize it's a sod house. Not very well insulated and pretty messy when it rained. But that was good if you had a clay soil. But in the sand hills, it's really sandy, so you don't get very good turf. And we begin to suspect that maybe they thought about using the straw bales because the local people used grass to build their homes in this area. Kind of a straw igloo, and it would have very nice thermal properties in those cold winter nights, and a very renewable resource with all the grass in the sand hills. So perhaps one of the Native American workers on one of these farms was watching them try to build sod houses, and the sod kept falling apart, and maybe just suggested they use these newfangled bales of hay to build a house. So in the late 1890s, baling had been introduced, partly to move hay along the railroad. There were both horse-powered balers, where the horse just walked around and around and around, driving a lever which compressed the hay, and they also had the first steam-powered balers. So these are one of the first houses, and everybody gathered. I don't think everybody there was living in the house, but people got together to celebrate putting the roof on. Materials, even for the roof, had to be shipped quite a ways and were very expensive. So these are houses which demonstrate minimal material use. As Mott's can say, having been up in the attics of these, as I have, there was no wasted wood. These were usually just a free suspension roof tied together at the peak and with almost no interior cross bracing. Yet they survived a long time out there in the Great Plains. And one of the reasons for these pyramid roofs is it's a minimal use of material. It's also a very stable roof in high winds. So one of the complaints there is the high wind. One of the reasons many people built straw bale houses was for quiet when those howling north winds were blowing, to keep from going insane out in the buildings. And they were able to find in various expeditions that Mott's has been on with other people. This is probably the earliest homestead in 1904, 1905. And it appears from the look of the concrete that the concrete was poured into forms that were put up against the hay bales. And this has been abandoned for many years and is in pretty much in need of a roof now. If anyone feels a great commitment to straw bale construction, they could arrange with the owner to put a new roof on this, so it lasts for another 100 years. Active buildings from that period are still to be found. This is a bunkhouse at the Fawn Lake Ranch, built in 1914 or 1915. The Straw Bale first story was remodeled, and this little addition was put on top. It's still an active working ranch. And one of the more visible structures in the heart of Arthur, Nebraska, one of the thriving metropoli of the plains, is the Token Holiness Church, built in the 1930s, of rye straw, contributed by one of the parishioners, and it's held up reasonably well. And it has the apartment for the minister in the back and on the upstairs.
What does reasonably mean?
Reasonably? As well as a conventional building to hold up. Let's put it that way. It had been abandoned for a while, and the local historical society sort of re-roofed it and tidied up a few cracks in the outside. But the interior was refinished and refurnished with sort of period furniture. And you can imagine the family living here for 30 or 40 years while the church was in use. The Monarch house is one of my favorites. It's one that I've stayed in, still in the second family that's owned it. You see all these trees now. You wonder why didn't they use trees when these houses were built, but you see the old historical photographs, and Mott's may have one of them in his slide tray. There were no trees when Arthur was settled. This was just barren grassland. And once the cattle were introduced, there was quite a bit of blowing sand. And the house has been hit by lightning. The only damage that was done was it set a box of Kleenex on fire in the kitchen. And you might wonder how these houses are tied together. One of the questions is always, how do you tie the roof down? In this case, they just sort of pushed the stucco up over the plate and tied it down with the stucco. It seemed to work pretty well. And you can see that this was original. These were 2x4s. These were not 1 5/8 or 1 3/8. Little stuff back there. One of the nicest houses is built a little bit later in northern Nebraska. The woman who lives there helped put the roof on when she was a young girl, and still in the family. This has one of the few cases we know of with a straw bale basement, so about 2/3 of the basement is straw bale as well. And not something you can do in too many climates, but here with a fast draining sandy soil, it seems to have worked out pretty well. Not shown in this picture is the big satellite dish, which is right next to the house. It provides kind of a nice juxtaposition of the old and the new, or the sustainable and the computer under the grassy knoll. The inside of the house is very nicely finished, and really no cracks or any signs of distress in the building. Very beautifully done. There have been a few commercial buildings. This is one of the early ones from 1948 in Wyoming, a grocery store. Started a little cluster of buildings in this area. This is one of the many different techniques of using straw bales and hay bales. Quite often they're just stacked up and pinned together. In this case, there was actually mortar put between the bales, using them like big bricks, and with a running bond in most cases. The building is still in use today. It has a few cracks in the walls. If you look at the gutters, you'll see that there's no drainage. The water just puddles up along the building with a fairly minimal foundation, so there's a little bit of frost heave going on. But taking a look at the straw inside these walls, it looks very fresh, still in quite good condition. And when many of the early Nebraska houses were taken down because the area is being abandoned by people leaving the area, the cattle were very happy to get to the hay inside the walls, because it had many of the prairie flowers and grasses that had disappeared in the 50 years between the time the houses were built and when they were torn down. There's another commercial building in Lincoln, Nebraska. Apparently started out as a house of ill repute, gambling, and other nefarious activities, and at last account was still involved in activities that might not be considered entirely lawful. Signs inside the building saying, "Be sure to lock door." at all times. So that's one on there we might want to know about. A little church up in Sexsmith, Alberta, about as far as you can get from anywhere in Alberta, 6 or 7 hours out of the city. Still in use today and built in the 1950s. And kind of the end of the straw bale and hay bale building for the first round. Many farmers kept building straw bale garages and sheds. It's material they had on hand. They knew how to use it. Professor I worked with down at San Diego State's father had a straw bale tractor barn on his place in Kansas for about 30 years. Nobody thought anything of it. It was just something that the farmers did. In the 1970s, a book came out called Shelter, which some of you may have seen, and it had a one-page description of hay bale construction, and it really triggered most of the modern resurgence in its way, done by an English professor and philosopher, man of all trades in Nebraska, and really got us started not only in California, but in the Southwest and Canada, and from there it's moved abroad, and Mats will talk more about how far abroad it's gone. I am not too familiar with the more recent developments, but buildings in how many countries now would you guess?
I don't know for sure.
20?
Maybe.
15 or 20? Including Mongolia. And this is the first house I was at all familiar with, built by my former boss, John Hammond, up near Winters, California. Was featured in Fine Home Building, and also triggered some interest in straw and hay bale construction. A very nice little, this is a hybrid building, kind of a cross between a pole structure and a load-bearing structure. And other people, out of desperation, found straw bales to be a useful compromise for people without enough money to build a real house. Athena Steen, one of the co-authors of our Straw Bale House book, built this little passive solar straw house in Santa Fe when she was going to school. She and her husband put together a shelter they could live in for just a few $100s while they went to college. And behind the south-facing windows are 55-gallon drums full of water. We'll talk about passive solar adaptations a little bit later. But the super high insulation value, easy construction, and possibility of putting together something quite inexpensively attracted one end of the straw bale spectrum. Up in Canada, a number of homes have been built by Louis Gagne and friends. Some fancy custom houses, and this is an art studio in Prince Edward Island, timber frame with a straw bale infill. Canadian builders managed to talk their equivalent of housing and urban development out of research money. Really the first straw bale research that was done on strength, moisture, issues at that time. And when I started writing about this in 1984, 85, that was some of the first information that really turned up of serious research that was being done. Of course, the United States building establishment wouldn't consider any of the Canadian tests because they were metric, and heaven knows what the Canadians do for research, so it provided some help for us here, but everything has had to be repeated in the United States. I became interested in it largely because of work on sustainable agriculture issues and the problem with straw disposal. At the time, John Hammond was working with straw bale. I thought it was kind of a quaint and interesting idea, but I was not too excited. But when I got involved in the rice straw problem in California, I suddenly saw the real potential this would have for use of a waste resource. Right now, there are about 1 million tons of rice straw produced every year in California, sometimes 1.5 million, sometimes only 1 million, and the rice growers need to get it out of the fields. Traditionally, it's been burned, so they can burn a field for about $3 an acre, and if you can imagine burning even a fifth of this each year, which they're doing now, 200,000 tons of straw being burned produces lots of smoke, lots of health problems, and we're trying to phase it out. You might think you could just till it into the soil like you can with wheat straw, but because it has such a high silica content, it doesn't break down fast enough, and it tends to create weed problems and generate methane. So we can't really do that. And here's a real small rice burn going on. And if you live next to this rice grower, you can imagine you might be calling your legislator and saying, we really got to do something about the straw problem here in California. So a number of things have developed, both from the rice growers, and surprisingly the other very active group has been the North Coast Fishermen's Association. And the North Coast fishermen see using rice straw as a way to reduce pressure on the northwest forests to protect their salmon fishery. This is Rick Green, one of the rice growers, also a builder. He's been very active in helping people get rice straw bales and producing building grade rice straw bales. And he's currently involved in a project with Caltrans to build a sound control wall along the freeway in Colusa County. They're still quibbling over details and the engineering and the cost, but it looks like at least a partial section is going to be built with rice straw bales. They're trying to get rid of it. So if we can find uses for it, it doesn't have to be very expensive. And rice straw isn't the only rice or straw problem. Straw is burned all through northern Mexico and now in many other parts of the world as well. When people were doing a lot more mixed farming with animals and crops together, the straw had value, but now it's just a problem that they're trying to get rid of. 1989, we held the first straw bale. What the heck are we going to do with these things? How do you put them together? Meeting in Oracle, Arizona. Sort of a brain trust gathered. Motz and I and Bill Steen and Plenty Fisk, another building specialist from Texas, and we got a few people kind enough to put some money together so we could experiment with putting bales together and how it might all work.
These look like they're on the flat.
Yeah, they're typically laid
Some
flat.
of the earlier pictures you showed them on the...
Right, yeah, well, Motz will talk more about it, but this is the easiest and most stable way to use it. And taking notes, trying to figure out what the best approach would be. This is an idea that's pretty much drifted away now of doing these metal ladders for lintels and headers, and more commonly now doing the load-bearing window frames and doors. Affordable. This is an older slide. Still is affordable. Many people have built very inexpensive houses, but we can now safely say the price range goes from $4 a square foot up to probably $220. Take your choice. Where do you want to be? There's one in New Cuyama, California, that was built for about $4 a square foot without benefit of permit. And there are also a number now that are being built in Mexico for down in the $1 to $2 square foot range in Sonora. More typically, particularly the contractor involved in construction, the cost turns out to be just about the same as conventional construction, but much cheaper than an equivalent super insulated house. We're talking about walls with R values of R55 perhaps, and to get that with conventional construction, we have to start going to double twin stud walls or very heavy foam insulation. And this is one of the low-cost houses. Why bother to plaster it? Not too expensive. And even after a number of years, the straw tends to hold up reasonably well. A little more likely to have pest problems if there's no plaster on the inside and outside of the house. There's another one. Again, you can see they started to plaster it, but went, it's a lot of work. This one's up in eastern Washington.
How long might it last without plaster?
Probably 20 or 30 years would be a safe bet. One of the other major uses for straw bales has been for potato storage. So there's a lot of agricultural use of bales in the past, and they figured a 15 to 25 year life of the potato storage structures without plaster.
Was that Tenasket?
Yeah, that's the Vanessa one.
As far as I know, that house still is not plastered.
Okay.
The bales were laid right on the ground. There's a lot about it you wouldn't perhaps want to do,
Yeah.
but it has survived.
What's the explanation for its survival?
Oh, I think they'd survive most places, really.
pretty dry there.
Relatively
Decent
dry.
overhangs.
Cold in the winter when it's wet, so there's not much decay takes place. This is one of the houses that really helped move things along. This is the co-author of Mott's book, Steve Mcdonald's house in Gila, New Mexico. It's one of the counties that's attempted to secede from the United States several times, but it's also been the home of much of the interest in straw bale construction. Very simple house, recycled materials, owner harvested poles from the forest, and cost ended up about $7 a square foot at the time. And very, very beautiful house. Simple house.
No paid labor.
No paid
Not a cent
labor.
of paid labor. You've got to remember that when you deal with these,
For the costs.
$5, $8, $10 square foot houses. All labor donated or by the owner.
And in this case, Steve even sieved his own sand, so this was the basic project. And in 1990, we held the workshop down at the Canelo project in southern Arizona, and this helped get things started in Arizona. This is a earth plaster stabilized with asphalt. And it's not particularly pleasant to work with. It has a little too much asphalt smell to it, but it's turned out to hold up quite well. It's got a little flex to it, and it's very inexpensive. This little studio is done by Bill and Athena Steen. Athena is in the blue shirt there, plastering. We'll show a finished picture a little bit later. And because it's such a small structure, the bales were stood up on edge to take up less space.
What proportion of asphalt to earth do you use?
Got it in the book. I don't remember what it is. It's, remember, Moss?
What?
The asphalt stabilized ratio.
Oh, they usually talk about 5% by weight is an average.
Yeah, I think this was less than that.
I
It's a
go
very
into
nice-
some detail on it in building the bales.
And it depends on the soil type and how much clay there is. A lot of these things, there's really no good formula. You have to do test panels and see what happens. Anything to do with earth. So this is the studio finished. We spent quite a bit of time straightening out the walls and getting them nice and tidy. One of the problems that happens with putting up straw bale walls is it goes very quickly. And what's known as the straw bale frenzy develops. And doing all the walls within 6 hours doesn't seem good enough if you could do it in 4 hours. So you really have to watch quality control.
That doesn't look like asphalt.
rates
So
for building.
the
This
plaster
is
thing,
skim coat over the top.
and it holds on, asphalt doesn't resist.
No. And we had a very courageous woman in Santa Fe, Virginia Carabelli, who decided she liked this approach. And I think, were you an advisor on this, Mutz? I think you were.
I went over and supervised the wall raising.
And she actually got a loan and permits and did the whole thing straight up and straightforward.
Bank
Insurance, bank finance. And a very beautiful house. It's on the cover of our book. Very simple, but one of the reasons it's been so popular in New Mexico and Arizona is it has the look of a double adobe wall, and the price is much lower than adobe construction. It's also much better thermal performance and much easier to build. And then there's all kinds of houses in between, built by people in many cases who hadn't built anything before, and you get some unusual details when that happens. But it's nice that people could have that opportunity. You may not finish all the straw bales inside, so you can brag to your friends that it's a straw bale house that you're living in. In this case, you can see the expanded metal lap on the corners. Makes it a little easier to get a good plaster surface. And this house was just a regular mud plaster inside. If it's not in the rain, why invest in the stucco or plaster? And kind of a nice detail here of the poured concrete sill. Just like a wood house, you don't want water to get into the walls. The composition of straw is just about the same as wood, but because it has all the little air holes and pockets and small fragments, it's perhaps a little more susceptible to moisture problems. Lots to talk more about the different options, but there are really just a couple. We can talk about load-bearing houses, and we thought at the beginning perhaps this would be the way many of them would be built, where the bales themselves carry the weight of the roof. And it's still one of the nicer systems for minimal cost if it's being done by the owner or someone who has the time to fuss with it. They just finished a load-bearing spec house in Los Osos, which I'll show you a little bit later. 2,200 square foot house built this way with permits and everything, which is now for sale. If you get the urge afterwards, you can go buy it from the builder. And one of the great advantages of these homes is the high insulation value, and the mass from the plaster inside makes them quite stable thermally. This little tower was going to be a cooling tower, but it turned out they didn't need the cooling system, so they've gotten away from it. And there's lots of little cottages, various kinds. This is probably what I'd end up building if I get the chance, just a really simple little house. The bales, one of the first questions people were interested in was how strong are the bales? Well, it turned out in the tests that were done in Arizona that Max and David Eisenberg helped with, a graduate student did his master's thesis on bale strength, and with a very interesting homemade rig, they discovered they were quite strong. But unlike many building materials, they're flexible. So you can think of a straw bale as a fairly stiff sponge. So if you push on it hard enough, it'll compress. If you let go of it, it'll spring back to some percentage of its original height. And it's not things architects are normally used to with their building materials. So you have to look at things a little differently and design them carefully to avoid getting into bale surprises. One of the few outright failures of a structural nature was done by an architect. And I have to say up front, my brother's an architect. I work with architects all the time. But in this case, the architect had made a very strong metal header to go over the door. Unfortunately, didn't have it sticking into the bales very far. So here was a very heavy metal bar sitting with just a little bit into each bale, and while no one was paying attention, it just fell out. So anything that's being expected to carry weight on the bales, you have to spread it out over a fairly large area of bale surface. There are a couple of different sizes of bales. The more we look, the more different variations you see. So you really generally like to have your bales before you start designing your building, or at least before you finalize your construction plans. You'd like to know who the supplier is going to be, what shape they'll be, and whether it'll be a 3-string bale, the bigger one on the right, or a 2-string bale on the left, which is a little smaller. The weights and ease of handling depend a lot on what kind of straw they're made out of, how dry the straw is. But typically maybe 90 pounds for the 3-string bale and 60 or 70 pounds for a 2-string bale. The greatest advantage to me as a former solar designer and someone who worked a lot on passive solar construction is the insulation value. The R value is about 2.4 per inch with the grain, and these are anisotropic materials. They're not the same in all directions, and R3 across the grain. So whether they're standing on edge or laid flat, the insulation value is about the same, somewhere in the R50 range. Construction is quite flexible. It's one of the things I like about them. They can be straight walls, they can be bent and curved into a fairly tight curve. Although you have a few things you have to watch out for when you bend them. And they can also be used as an insulating material overhead. And quite often builders are trying to combine the overhead straw and walls to minimize their purchase of materials from outside.
David, is there a source for the R value?
Yes, and it's in the book. Remember it offhand, Max?
It's Joe McCabe's master's thesis.
So
there's going to be some testing that will be happening very soon at Oak Ridge National Laboratory, because there's some controversy going on now about whether Joe's values really were accurate. And we suspect they are, but somebody at Oak Ridge did a different kind of a test and came up with much less R value. And so David Eisenberg is going down very shortly and building a wall, and they're going to be doing standard kind of whole wall test down at Oak Ridge, and hopefully that's going to give us a definitive, credible, once and for all answer.
Or one type of straw under one bale. And lots of opportunities to make for happy homeowners.
Excuse me, David?
Yeah.
The picture with the bales on the roof, those were actually 90-pound bales stacked
right
on the roof?
Right. And in that case, they had a very inexpensive source of truss joists. So they were getting truss joists for about the cost of 2x8s, so the additional weight was not a problem in terms of cost. One of the first permitted houses in the United States, and the first in California, was done in Lone Pine, California. It's a passive solar house done by Ken Haggard and Polly Cooper in San Luis Obispo. Very high performance house for a fairly difficult climate. Since they're sitting in a very active fault zone, the building codes required a timber frame. It wasn't possible to do a load-bearing structure, but a very sophisticated house. The biggest problem on the house was not the straw bales, not the earthquake engineering, but it was getting permission to do a gray water treatment system on site. And the high insulation value makes it very nice for doing insulated structures. This is for a water tank. This is David Exline, the builder of the load-bearing Straw Bale House in Los Osos. And I found the structure to be much prettier than the house, so I was going to move into the water tank building if I lived up there. Stable, 62-degree temperature, as long as they've been there since they got the straw bales up in the water tank. This is an excess of thermal mass, but it gives you an idea of the benefits of thermal mass. And this is the detailing inside the house there in Los Osos. One of the clues to straw bale construction is these very wide sills and wall profiles. Some of the people in Nebraska weren't even sure what they were living in, whether it was a sod house or a bale house. So one of the interesting detective stories was to go back and look and see what they were really built with.
David, how common is it to go back to the chainsaw and trim those drawings?
Fairly common. This is the Haggard Cooper house in Santa Margarita, up here San Luis Obispo again. Just completed. The housewarming was about 3 weeks ago. This is a standalone house. There are no grid connections. It's all photovoltaic power. Very nice solar design. And the adjacent building is a architect's office, a very nice studio, a very large studio.
What's supporting the second story?
Pardon?
What's supporting the second story?
It's a timber frame. This is, as you'll see in a little bit, and you can see the rebar down here by the pond. The whole area was burned out in a wildfire in 1989. And the timber frame was built from timber harvested from the fire-killed trees. And just a little closer up, and the skylights there have Steve Bear's sky lids and automatic opening and closing lids underneath, operated by a gas vapor system. And then the two water heaters here provide the hot water for the building. The two black windows underneath the main windows have water tanks behind them for thermal mass. It's one of the systems that I worked on for quite a while and helped pioneer back when solar made sense. And here's another detail of water wall, the water tanks in the architectural office. The upper purple line is a light shelf for daylighting, so it's all naturally lit. Very beautiful building inside. And Ken Haggard, slightly overexposed, and the energy system for the house, battery banks down behind him, and this is the brains of the system, the inverter, and the control systems. And the house was all built with renewable energy as well. The photovoltaics provided power for the construction. And the reason they did this is because they found out that straw bales were quite fire resistant. We already knew that from some of the tests that have been done in Canada, some other tests that have been done in laboratories, but there's nothing like a field test to really show how good a straw bale construction can be. This is the 94 fire in 1989. Burned out a wide range of homes in this area. The fire was hot enough to melt Ken's Volkswagen in the driveway. You might have seen it in Newsweek. The pool of metal from his Volkswagen running down the street. It was hot enough to kill most of the concrete, so the concrete spalled from the heat. And in many areas, the building was about 2 inches high after the fire. What survived? Just one thing, the straw bale bench, which had been built not long before the fire by some Native American kids on a little project. Not too carefully built either, but it survived at very high temperatures during the fire. It had been colored, and the color was burned out, so it was turned back into almost white color. There was a second bench up on the hill, and these were just built on a 2x4 frame. The other one, the 2x4 frame, was exposed. So the fire got under the straw bales by burning the wooden frame. The bench still looked pretty good, but somebody touched it one day and noticed it was kind of warm, and the volunteer firemen couldn't let that go, so they broke open the bales and they found out there was a smoldering fire in another bench. So it has to be sealed all the way around to be fully safe from fire. But in the fire test in the labs, if you look at the video that, is it Black Range, they call themselves, have a nice video on construction, engineering, and testing. 2,000 degree furnace on one side. After 2 hours, the temperature on the other side of the bale wall had gone up only 6 or 7 degrees. So very good fire characteristics. One of the reasons they're fairly difficult to burn is that they're very densely packed. It's like setting a telephone book on fire. So the first thing that Ken and Polly did was build a little studio to live in. This is a delightful little cottage, built again with materials, many of them from the site. We have these very low-cost truss joists, and this is where the picture was taken of the straw bales used with insulation of the roof. And here it is finished. Again, the sky lid in the skylight. Very charming little house that they lived in for the last year while they built the architectural office and their new house. Ideal for homes and commercial buildings in many cases. In some areas, straw bales are hard to get. If you have to ship them very far, they start to get expensive. But where you do have straw available, it's really worth taking a close look at straw construction and straw bale construction. There are also other options that are worth considering, including some that Bill and Athena Steen are working on and are much more common in Europe, of mixed straw and clay. It's mixed kind of a light straw, mud, honeycomb, kind of like a Brillo pad in the kitchen. Again, very nice thermal performance and very easy to operate. Commercial uses are what I'm most interested in now. Mott's found a farmer up in Alberta, I think, who is using temporary straw bale structures for his pigs. And having worked on some pig structures myself, pigs are just like us. They like comfortable conditions around 65, 75 degrees. If it gets too cold, they get mean to each other. If it gets too hot, they get mean to each other. So pig farmers are really concerned about conditions in their structures. And this farmer was finding that he could build a straw bale structure every year, including a very big one like this, for about the cost of a loan on a conventional building. And every year he'd tear the building down at the end of the year so he'd have a nice disease-free structure at the start of the year. This is a little straw bale weigh station in Mexico. And ideal for construction purposes in many parts of the developing world. It's one of the areas for very rapid growth, I think, you can expect in the future. and quite a bit of work has been done in Baja now. Where'd Skip go?
He's outside.
Oh, he's outside. Skip's got a little community center down in Tecate, and there's quite a bit of work going on, San Felipe, La Paz, and throughout the Baja Peninsula. You can also do a straw bale retrofit on many types of buildings. This is your basic starter kit. And this is one of the other options. In addition to load bearing, you can wrap structures with bales. People have even wrapped 2x4 construction houses and metal buildings, and would be perfect for wrapping a cinder block or stone house, which has would then have almost infinite thermal mass inside a highly insulated shell, and you get a very good performance. And load bearing, I think this was the first load bearing permit in the United States. To be my guess, this is Grandma's place at Motz's in Tucson. And a very nice suggestion for the mother-in-law straw bale, a small cottage.
Were those black verticals poured?
Can you go back, David,
Yeah.
on that slide? That's not Mom's place.
Oh, it's not?
No.
No, I've been telling people the wrong story for a long time, man.
Well,
Where is it? You
I'm
know?
trying to figure out, I mean, well, maybe it is, but there's something peculiar going on here.
Maybe it's backwards.
Okay,
That's it.
I think it's reversed.
Okay.
But it's
Catch
still
you by
Mom's, right?
surprise.
Mom's reverse is still Mom's.
It doesn't look right, huh?
This is load bearing.
It is load bearing.
Those black strips are just pieces of roofing felt covering the polyester tie-down straps to protect them from UV.
Yeah. Sorry.
Only for the
I'll
temporary
turn it
until they
around.
get stucco, right?
Excuse me?
Temporary protection from UV.
Yeah, yeah, we stuck it right over it.
And this is the X-Line house again in Los Osos. One of the beauties of these houses is that even if you don't do a good solar design, you can still get acceptable performance even if it faces the wrong direction. In this case, this house faces west because there's a very nice view out there. You always tend to find that the prettiest view is always in the wrong direction, and that can compromise building performance. But the very high insulation values help you out in the thermal mass system. Another passive solar straw bale house, again just south-facing windows, and additional thermal mass inside helps. Exposed slab or concrete can be very effective, and now there's some very beautiful finishes for concrete that you'll never suspect that it was concrete. And we have a concrete finisher here tonight, and I'm sure she can answer any of your questions about some of these finishes. For a look at some of the things that can be done, we have a straw bale cluster at the Tree of Life Nursery in San Juan Capistrano. Just east of San Juan Capistrano on the Ortiz Highway, they have a straw bale barn, straw bale visitor center and kiosk, and they're just completing a straw bale office. And the office has just a beautiful floor. This is the architect's office. It's a beautiful studio. There's probably 7 or 8 drafting tables, computers and things are scattered through here. Very nice light, very good working conditions. There have also been a few interesting temporary buildings. This is one in the backyard, and the straw bales have been put on edge again to save space. Pallets were put down for the foundation, not generally an approved detail by the building code, and all nicely finished up to make a home away from home in case you've got to have get some writing done or studying or sleeping. Compromise. This is the Tree of Life Nursery under construction. Very nice combination with pole frame structures. You can put the poles up and do the roof, and then put the straw bale walls up underneath. One of the things that we're tending to find out is that whenever you do a straw bale building, even if it's never rained there before, it will rain while you're doing the straw bale building. So having the roof up first is a real advantage. The bales are quite fire safe, pretty much by themselves. Once they're plastered, they're extremely fire resistant. But during construction, you get quite a bit of straw spread everywhere. And at that point, it's actually fairly vulnerable to fire because you've got lots of little pieces of very dry straw all over the ground, all over everybody, and you just have to keep an eye on things. Make sure you have a water source and a fire extinguisher, and police the area at least once a day and remove some of the loose straw.
David, you were showing some of that rebar. In California, can you get away with using cane?
It really depends where you are and what you're attempting to do with it. I personally like bamboo. The carrizo is a little too soft. And arundo is a little too soft to be very useful. But in addition to, this was the first method we came up with. It seemed like a good idea at the time. Increasingly, people are thinking about doing the reinforcing outside the bales. Because if you think about it, having in the middle provides the least resistance to distortion. It does keep the wall from falling over if you're having a tug of war on top or some kind of water fight. But Bill and Athena Steen have been doing some of their very low-cost structures in Mexico with carrizo on the inside and outside tied together. So you have your stiffest elements on the outside of the panel.
What is carrizo?
It's the big weed you see in all the drainages here. It's a relative, or quite a relative of bamboo, but it's noxious weed that was introduced.
Were these rebars driven after the bales were set?
Yeah, these were driven after they're set. Quite often there's an impaler that's put down in the slab and they're dropped over it, and Mott will show you a lot more about the actual construction details. This is a little history, and this is just again a confirmation that it will rain in places where it never rains. This is a little seed storage building that we did in the Mojave Desert, an area where it rains 4 or 5 inches a year. In a wet year, during the 2 weeks we were doing this, we had 6 inches of rain, plus snow. So we got everything. And this is another one with a straw bale insulated roof. Both the Tree of Life Nursery and this building, one of the goals is safe storage of seeds over a long time, so you want very stable temperatures, about the temperature you might like to store wine. The old and the new, some of the really nice adaptations are these hydronic heating systems under a super insulated building, a very nice combination. I wouldn't consider this really an adequate tarping job. It's not bad. Lots of people just throw something over the bales and assume that it will be there when the 40-mile-an-hour winds hit. You really would like to have the bales completely covered and very well tied down to protect them from rain. We have a straw bale construction project going on campus right at the moment. The students are doing a straw bale amphitheater here behind our sports building, and we admit it, we're the ones who made it rain. They just got the first bale ready to plaster last week, the first bench. And I should say, finishes can be very fancy or very rustic, as you've seen. This is one of the upscale examples, and some of the houses in Santa Fe have gone to the $200 custom range with very beautiful finishes, and some have done a very nice job for much less and still have very nice finishes. This is another one of the Santa Fe straw bales. It's not just something rustic that hippies do in New Cuyama or Descanso or out in the desert. It's really become an accepted building material in several parts of the world, increasingly in California. The far greater challenge, however, is Mexico and places where there aren't many building materials, except perhaps some rusty rebar and some barbed wire. And this is what Bill and Athena Steen have been working on recently in Mexico. Very low-cost structures. And the straw bales integrate very nicely with the conventional Mexico concrete frame structures. A number of houses now in Ciudad Obregón, and Bill and Athena are now working on a 5,000 square foot commercial building using the same sorts of methods. The target for their low-cost houses here, lowest cost houses, is trying to get the cost down to $1 per square foot, $2 per square foot. And here you can see the carrizo on the inside and outside of the building to stiffen the walls. an attempt to do a low-cost insulated roof with a mud straw mixture. And this is a Department of Energy sponsored Straw Bale rammed earth house in Ganado on the Navajo lands. A very good example of why we haven't gotten the government involved. This project probably cost more than any other house built. It's taken longer, it's tied up in all sorts of mistakes, and it was only the gracious talents of David Eisenberg that saw it finished at all.
There's actually Adobe.
Adobe, the other hand. But still an attractive house when it was finished, and a good place to be.
Who did that slide?
Probably Bill.
It's a great picture.
Books and booklets. This is a little out of date now. We have since gone through the editions that Skip showed you of the Straw Bale House with color pictures and Build It with Bale Part 2. And I think that's about it. So I'd be happy to answer any questions you might have, and you might take a quick stretch after that while Mark sets up for how you actually go about building a house like this.
Is there a way of telling the moisture content of the bale?
Yeah, the standard homebrew method is to weigh the bales, and if you see lots of variation, you can find the lightest bale and make some estimates from that. They also have a number of meters you can buy, which are used by stockmen and ranchers to assess bale moisture. But there's nothing really cheap.
Right behind you, on the table.
So
Mark will explain that more.
I'll explain this one a little more. Just the probes you can put in to get a moisture measurement. There's a very nice low-cost instrument called Hobo, which measures relative humidity. It's a little matchbox-sized computerized monitor, which you can link to your PC or Macintosh. Very nice way to follow relative humidity in a bale wall over time. You can program the little hobos for up to a year. You can have repeated measurements. Very easy transition to a computer system to
You
get
have to
graphs.
contain it in a plastic bag to do that?
No, you just put it into a hole that you left in the wall probably. And we'll be doing this with the Haggard house. The builder there left, sort of electrical outlet-sized holes in a number of places so they can put some meters in to monitor change. Now the Canadian tests followed relative humidity. That's one of the things they were concerned about in Quebec, a moist, cold climate. And the humidity actually went down over a number of months and then has fluctuated pretty much like it does in a conventional wood structure. There's seasonal ups and downs. In terms of concerns about hot, moist climates, one of the more amazing buildings that I still haven't seen in person is the Burritt Mansion in Alabama. This huge mansion built in the 30s? 1938, and now it's been incorporated in the city park. So it's this huge mansion built with straw bales by a somewhat eccentric and peculiar character, but has held up very well in the hot, humid South. So properly detailed, well built. They don't seem to have any obvious end point in their lives. They should be used for good for several hundred years. And the house that we had hoped to look at in England, which might have been almost 600 years old, conceivably had the original barley bundles in it that had been used when the building was built. So very nice in terms of durability, energy efficiency, comfort, and worth a close look. So yeah, true.
What's your favorite lateral system?
Well, my favorite system, and Mats and I might disagree on this. We haven't had a chance to catch up to see which directions we're headed. But particularly in California, I'd really look to doing a metal frame and carrying the load all on this limited number of metal foam and using the bales mostly for the flow.
It's a 5-pole thing.
Just inexpensive, relatively easy to do. Put the roof on first, or pole structure would be another option.
And then you don't use the rebar.
So you wouldn't have to do the rebar. You can do inside and outside bracing instead. Maybe use like remesh on the inside and the outside tied together.
Remesh, is that the same as standard metal?
No, like a 4x4 grid, like you use in the slab. Oh. It's a little higher strength. But that's my tendency right at the moment. And I had a student down at San Diego State do a big search of metal buildings for me, and I look at all the manufacturers, and between all the different options that are out there, you can put together a pretty nice system that would be conventional building to metal frame builders that they would have trouble with. A number of years ago now, we did a demonstration Straw Bale House at the Orange County Home and Garden Show, and they had a metal truss system for the roof that was done there. And the people who were doing that were very impressed with how easily the two integrated together. Seems like about as far apart as you could get as the sort of the most recent metal frame, one of the most primitive methods of putting the walls up, but it worked out very nicely together. The only hazard is if you've got too many grinding wheels or too many welding torches around the straw, that you have to be extra careful of setting yourself apart. So that's probably what I would do. Either that or the Mexican style with a concrete space frame, I guess you'd call it, concrete columns and beams. Particularly anywhere in Mexico, that's what everybody knows how to do, so it works out very easily. Any other questions?
Is anybody doing arches yet?
Well, many people are doing arches. I think it's kind of folly myself. It's just arches require rigid materials, and the bales aren't rigid. There's some interesting things. They seem to be working in some cases, but you're working against the basic nature of the material. The advantage of trying to do it, and the reason people are so interested, is for places where there are no other materials except for straw bales. How do you do a roof system without anything else? And that's why they're so interesting. At the Canella project one summer, we did a very big arch. It was probably 12 feet high, 10 feet high.
Yeah, I think what David's calling, or you called it an arch, what we're really talking about is a vault. An arch is just, like that.
You can vault it
A
ceiling.
vault is an arch.
Through space, right.
Right. So people are doing vaults and domes. I've done 2 domes.
How are you holding up?
They're doing fine.
Domes and straw.
They're small. I want to go bigger the next time.
And this big sample one we did in Arizona worked out reasonably well. We ran out of bamboo near the end, so they pinned the last parts with a rundo. They hadn't worked really hard on the foundation when they started it. And everybody sort of turned around and was looking the other way, and it went, oh, whoop.
So quiet.
So, and it wasn't that quiet. The ground kind of shook. It was probably on the seismographs of Arizona. So,
I think there were some very obvious reasons
it was that
why that one went down.
Yeah, the foundations weren't even. The
Would not do
reinforcing
the
wasn't
next
very
time.
good. But again, it's really not ideal way to use them, I don't think. But where there's nothing else, then you've got to figure out a way to do that. And one of the possibilities is some of the things that some of the most beautiful straw or bamboo type buildings in the world are done by the Marsh Arabs, people who now live in sort of eastern Iraq, and many of them have been rubbed out by Saddam Hussein, but they did beautiful temples with bundles of arundo, so they have columns as much as 3 feet in diameter, huge arches with these fiber columns, and that would be something you can do for reinforcing if you get that kind of material.
We'll have a chance for some more questions later, and maybe, guys, we're like an hour and a half